So in this first part, we're going to talk about quasi-experimental designs. And these exist for situations in which complete experimental control is difficult or impossible, right? So for example, in the real educational world, the world confronting the educational researcher, it's possible that the school system may not allow interclasses to be disrupted or divided to provide for random or equivalent samples, or may not allow for a treatment to be given to some and withheld from others. Quasi-experimental exists for cases where the power to randomize is either seriously curtailed or altogether absent. In other cases where the researcher might have access to only single groups, such as a classroom of individuals with learning disabilities or only one or two participants, it could be impossible, for the researcher to get what they want without doing a quasi-experimentation. And so we have developed in the research world specific research designs under the general headings of quasi-experimentation. When dealing with a one-group design, we first look at the post-test. So this is a treatment that's implemented or an independent variable is manipulated, and then a dependent variable is measured once after the treatment is implemented. So in our example here, a researcher who's interested in the effectiveness of an anti-drug education program on an elementary school's students' attitudes towards illegal drugs, the researcher could implement the anti-drug program, and then immediately after the program ends, they could measure the students' attitude towards these drugs. This is the weakest type of quasi-experimental design, and a major limitation to this design is the lack of control or comparison group. There's no way to determine what the attitudes of these students would have been if they hadn't completed the anti-drug program. Despite the major limitation, though, results from this design are frequently reported in the media and are often misinterpreted by the general population. So if advertisers claim that 80% of men noticed that they used this hair product and their hair looked better after using this brand for a month, if there's no comparison group, then that statistic is going to mean little to nothing. In the one group pre-test post-test design, the dependent variable is measured once before the treatment is implemented and then once after it's implemented. So if we go back to this researcher who's looking at the anti-drug education program, we can measure the attitudes of students at a particular elementary school during 1 week, and then we can run the program the next week and then measure the following week. And so this pre-test post-test design is kind of like a within subjects experiment in which each participant is tested under the control condition and then under the treatment condition. You might notice that the pre-test post-test design is similar to a within subjects experiment in which each participant is tested first under the control condition and then under the treatment condition. If the average post-test score is better than the average pre-test score, then it makes sense to conclude that the treatment might be responsible for the improvement, but we cannot conclude this with a high degree of certainty because there could be other explanations as to why the post-test scores might have changed. So it's difficult to determine for sure. So for the non-equivalent control group design, you can see we still have the post-test only as well as the pre-test post-test design. A non-equivalent group design is a between subjects design in which the participants have not been randomly assigned to conditions. So the post-test only non-equivalent groups design, we have one group that's exposed to treatment, a non-equivalent group is not exposed to treatment, and then the two groups are compared. So if a researcher who wants to evaluate a new method of teaching fractions to third graders, one way would be to conduct a study with a treatment group consisting of one class of third grade students and a control group consisting of another class of third grade students. This design would be a non-equivalent group design because the students are not randomly assigned to classes by the researcher. So there could be a lot of important differences between them. We don't know how the classes were made up. We don't know if there's higher performing students more motivated students in one class. We don't know if there's more disciplinary or troublemaker kids in another class. We don't know the teaching styles of each classes or the classroom environment of each one's. We don't know the different levels of achievements in each class. So these variables, or confounding variables we call them, could be the differences in why one class learns the fractions better than the other class. So this would be the post-test only type. Another way to improve upon the post-test only would be to design a pre-test post-test non-equivalent group design. So in this one, there's a treatment group that's given a pre-test, then they receive the treatment, and then they're given a post-test. But at the same time, the non-equivalent control group is given a pre-test, but then we don't give them the treatment, and then they're given a post-test. And so the question then is not simply whether participants who receive the treatment improve, but whether they improve more than the participants who do not receive the treatment. So if we go back to that example on the attitudes of the anti-drug program, so one school are given a pretest on their attitude toward drugs, then they're exposed to an anti-drug program and given a post-test. Students in a similar school are given the pretest, not exposed, and given a post-test. So again, if the students in the treatment condition become more negative towards the drugs, this can change in attitude. Could be an effect of the treatment, but it could also be a matter of history or maturation. It really is an effect of the treatment. Then the students in the treatment condition should be more negative than students in the control condition. But there could be, other reasons. There could be similar amounts of change. So this type of design does not completely eliminate the possibility of confounding variables. Something could occur at one of the schools, but not the other. So students at the first school would be affected by while students at the other school would not. If participants in this kind of design are randomly assigned to conditions, then it becomes a true between groups experiment rather than a quasi-experiment. With the time series design, in many ways, the single subject approach is similar to the time series analysis in that the stability and changes in behavior are studied across time or experimental sessions. This is characterized by repeated measures of the dependent variable over time with an introduction of the independent variable at a particular point in time. Because the time series analysis is characterized by relatively long-term measurements of some dependent variable, you have to be careful to consider extraneous variables that are often associated with repeated measure designs. In some cases, a change in the level of behavior may be a result of the extraneous variables rather than the introduction of the independent variable. The time series analysis is also a technique that is often used to track changes in behavior that occur on a large scale. For example, does a full moon make people more likely to commit crimes? One could track crime statistics on a daily basis over a long period of time and relate those statistics to the fullness of the moon. This is not an experimental design because there's no independent variable manipulated by the researcher. Thus, cause and effect conclusions would not be warranted. A time series analysis in which there's a bit more control would involve the tracking of crime statistics both before and after a new law is passed that increase the punishment for the particular crime. One primary purpose of such a law is to cause a reduction in the incidence of the crime. Even in the latter example, it's very difficult to verify the effect of the new law because there's many other factors that influence the crime rate that are likely to vary over time, such as the economy. However, this is not to suggest that time series analysis of such questions should not take place. What we do suggest is that we all need to evaluate such information with a very critical eye. If we, excuse me, if we go back and look at the interrupted time series design, we take a time series as a set of measurements that's taken in this intervals over a period of time. So we look at this manufacturing company that might measure its workers' productivity each week for a year. In an interrupted time series design like this one, there's a classic example where the treatment was the reduction of the work shifts in a factory from 10 hours to 8 hours. Because productivity increased rather quickly after the shortening of the work shifts, and because it remained elevated for many months after, the researcher concluded that the shortening of the shifts caused the increase in productivity. Notice that the interrupted time series design is like a pre-test post-test design, in that it includes measurements of the dependent variable both before and after the treatment. It's unlike the pre-test post-test design, though, however, in that it includes multiple pre-test and post-test measurements. One way to improve upon the interrupted time series design is to add a control group. But this involves taking a set of measurements at intervals over a period of time, both before and after intervention, of an interest in 2 or more non-equivalent groups. So if we go back to the manufacturing company that measures its workers' productivities each week for a year before and after reducing work shifts from 10 to 8 hours, this design could be improved by locating another manufacturing company who does not plan to change their shift length and using them as a non-equivalent control group. If productivity increased rather quickly after the shortening of the work shifts in the treatment group, but productivity remained consistent in the control group, then it provides better evidence for the effectiveness of the treatment. So with developmental designs, we look at longitudinal, cross-sectional, as well as cohort sequential designs. The longitudinal ones involve being with a group of people who may be the same age and background and measuring them repeatedly over a long period of time. One of the benefits is that we can follow people through time and compare them to themselves when they were younger. Therefore, changes with age over time are measured. Some of the advantages or disadvantages, problems with this type of research is that it's expensive, it takes a long time, subjects drop out. It's difficult to keep track of people for long periods of time, but the longitudinal research designs are used to examine behavior in the same individuals for long periods of time. We can study intelligence and aging. We can look at whether 20-year-olds become less intelligent with age over time, or if they become more intelligent as they age. There's a lot of different data points and patterns of intelligence that we can try and look at. We could start looking at somebody, person A when they're 20 years old in 2010, and then we can look at them again in, 2040 when they're 50 years of age, and then we can look at them again in 2070 when they're 80 years of age. The cross-sectional design is when we examine behavior in participants of different ages, but they're tested at the same point in time. So we have cohort A, B, and C. We're studying them in 2010, and cohort A is 20-year-olds, cohort B is 50-year-olds, and cohort C is 80-year-olds. So this would be a cross-sectional design because the researchers plan to examine intelligence scores of these individuals at different ages within the same study at the same time. We're taking a cross-section of people at one point in time, and we're looking at their intelligence levels and comparing what the levels of intelligence are. And then the cohort sequential one, this includes both elements of longitudinal and cross-sectional. Similar to longitudinal designs, sequential research features participants who are followed over time. Similar to cross-sectional designs, sequential research includes participants of different ages, but this research design is also distinct from those because the individuals of different ages are enrolled into the study at various points in time to examine age-related stages or changes, development within the same individuals as they age, and to account for the possibility of cohort and/or time of measurement effects. The differences between them depended on which variables we're focused on for the analysis of data. Ideally, we want to compare results from the different types of analysis, the effects of age, the cohort, the time in history. All of this could be separated out. So if we look at our example of intelligence and aging, in a study with a sequential design, a researcher might recruit 3 separate groups of participants. We've got group A, which would be recruited when they're 20 in 2010, and would be tested again when they're 50 and 80 and 20 and 40 and 2070, respectively. Group B would be recruited when they're 20 years old in 2040, and then they'd be tested again when they're 50 years old in 2070. Group C would be recruited when they're 20 years old in 2070, and so on. And so that's how we would collect the data and the ages and stages. So these are powerful because they allow for both longitudinal and cross-sectional comparisons, and they can be measured and compared with differences between age and cohort groups. The researcher could examine the intelligence scores of 20-year-olds in different times in history and different cohorts. This might be examined by researchers who's interested in socio-cultural and historical changes. But since the elements include longitudinal and cross-sectional designs, sequential researchers has many of the same strengths and limitations as some of these other approaches. So any of these fall underneath the quasi-experimental designs and provide a lot of insight and detail, but come with their advantages and disadvantages depending on what it is that we want to research. So there's more to follow in terms of quasi-experimental designs in the next video.